another point of view. For time less than 0, VC equal to 9 volt. Okay, VC equal to 9 volt. IC equal to C dV by dt. Okay, if VC is constant, take derivative of the constant, you get 0. Therefore, IC will be 0, whether you analyze from the overall physical point of view or in the VC equal to C dV by dt. Okay. Now we assume any transient in the circuit diagram long ago, leaving the pure DC circuit and it have no current through the capacitor. Therefore, you can conclude that during the time IC equal to 0 2. But for time greater than 0, you know VC no longer constant. VC equal to 9 e power minus t divided by 60 micro. Take the derivative of them. E minus A. You can see that E minus AT. Okay. E minus AT give you minus A EAT. That's why in the overall point of view, after you take the derivative of them, the current will be reverse direction. Okay. You can see that for time less than 0, the current flow in some direction. But for time greater than 0, the current will be reverse direction immediately. Okay. For the summary process, the summary of this procedure, okay, I will show you in each step. The first one, what happened to VC? For time less than 0, the switch is contact in here. The capacitor is full charge. If it's full charge, it performs like open circuit. Therefore, VC equal to the voltage source level. Then it equal to 9 volt. Okay. And for time greater than 0, when time greater than 0, the switch is open. If the switch is open, it means the source is no longer supply the energy to the circuit. Okay, you can remove them, and only one source that you have is the energy that's stored in the capacitor that it try to maintain the voltage at its B. If it will try to maintain the voltage at its B, okay, and it moreover, it deliver the power to outside the world. If it deliver the power, you can see that if it deliver, it means the current must be get out from plus or get in from plus. It must get out, right? It must get out. For time greater than 0, the capacitor try to pretend itself as the voltage source. Therefore, if it try to pretend, it means it must deliver or release the energy that it used to store. Therefore, it will become negative I. Okay. Now, for time greater than 0 is here. IC for time less than 0 is equal to 0, and time greater than 0, it will become negative by this reason. In the finally, you can see that VC can gradually change, okay? But for the other parameter, can sudden change or gradually change, depend on your circuit structure. But VC, it's impossible to make VC to be sudden change. If VC is sudden change, the current that came from its derivative will become infinity and it's broken so many devices after that. Any question? Hello? Are you asleep?
No.
Okay. It's your turn. Try to do it, okay? And I will provide you solution. Capture this question quickly. Okay, I give you 20 minutes to finish them, and I will provide you a complete solution to explain them. I think if I show you, I talk to you again, you can see and you listen, but you not fully understand until you try to solve them by your hand. Okay? Capture is in 5, 4, 3, 2, 1. For RC circuit, you can see that it have R and C, okay? You must use the RC technique to solve them. Okay? I'm still here. Okay? If you have any question, you can ask me. And I think okay. I will drink a water in 1 minute, okay? Okay. If you finish, okay, you can post in the, okay, you can show you in the, okay, meeting chat, okay, and I will provide you, okay, correct or right or wrong, okay, and will provide your final solution. ธนพัฒน์อยู่ไหน
ครับธนพัฒน์ก่อน
โอเคมันส่งไม่หมดนี่ไม่ได้ถามแค่วีนะถามไอด้วย
อ๋อโอเคครับ
แต่ดีแล้วที่ทำมาOkay, I will check your attendance. Okay, bye. Okay, before I download. Okay, the check attendance checking. Show yourself first. Okay, open the camera. Okay, now. Everyone open the camera now. Okay, to checking your attendance. Oh, some of your friend is already sent. Okay, if you're not finished, try to finish now. I give you another 5 minutes before I provide complete solution. Okay, if you are work hard, okay, it's good for you to take the final exam. Okay, but if you don't want to do, I cannot force anything. Okay, and the final answer will be provide you a poor grade. Okay. Kasadi, who is Kasadi? Are you here?
Yes, Ajahn.
Oh, is you never. I don't ask only we. I ask for the eyes. Okay. You don't see about. You don't capture about. Do you don't capture about the question? You answer incompletely. Okay. Do it more.
Yes, Ajahn.
Okay, I give you another 1 minute quickly. Okay. Okay. If you are finished, it's good. But if you don't finish, I have no time. Okay. Okay. We have another one topic must be finished. Okay. Before we go to the next topic, okay, I will provide your complete solution and the detail of this question. Okay. This question is about the R and C circuit. Okay. It's asked you for the circuit of the following figure. Determine and get the capacitor voltage or VC. And determine the voltage at time equal to 0, time equal to 2 milliseconds. After that, not only we see that the questions are for, it's asked you to determine and get, remember, determine and get the capacitor current. Okay. Now, if the circuit have the switch, okay, you must draw the circuit into diagram, okay, for before the switch is activated and after the switch is activated. In this case, the switch is activated at time equal to 0 second. Okay, therefore, determine VC for time less than 0 first. For time less than 0, the switch is placed in this position. Therefore, the capacitor is charging the energy to this resistor and this capacitor. For the left hand side, the branch is broken, no current flow in them. Okay. We can discuss that. Okay. And if the switch is already placed in this position for a long time, okay, it means the capacitor is already received the energy until it full charge. If it full charge, it means it perform like open circuit. We assume any transient in that circuit died out long ago, leaving a pure DC circuit. No currents through the capacitor because the capacitor perform like open circuit. Okay. If it open circuit, no current flow, right? Therefore, VC will be equal to this voltage source exactly. VC equal to 50 volt. We will use VC as the initial condition. The next one, determine 5 VC for the time greater than 0. VC for the time greater than 0, the switch is placed in this position. You can see that in this step for time greater than 0, we use another resistance, right? Now it's the capacitor no longer contract to the 732 ohm normal. Okay, it will be contract to 800 ohm. Okay, now if we contract in here, the circuit in the right hand side will be broken and no current flow. You can discuss them. Okay, now for this, okay, the you know R, you know C, okay, the resistance is 800, okay, and the capacitor is 2 microfarad. Therefore, the time constant is here, and 802 microfarad of Vc equal to V naught E power minus T divided by time constant, give you 1.6 milli. Yeah. Now, for time less than 0, in the previous step, okay, you know that Vc equal to 50 volt. For time greater than 0, Vc equal to V naught E power minus T divided by 1.6. Both of them is equal when time equal to 0. Okay. Therefore, from the third characteristic of the capacitor, it is impossible to change the voltage across a capacitor Vc by a finite amount in 0 time. Therefore, it means Vc for time less than 0 and Vc for time greater than 0 must equal. It will be equal when the switch is activated. The switch is activated at time equal to 0. Okay. Therefore, for 0 minus, before switch is activated, Vc equal to 50. Okay, after the switch is activated, Vc equal to V naught E power minus T divided by 1.6 milli. Both of them is equal, and you substitute T equal to 0 in here. Therefore, E power 0, anything power 0, give you 1. Therefore, you can conclude that V naught equal to 50 volt. Okay, V naught equal to 50 volt. You substitute them, you can get the general form of Vc. The capacitance voltage is here. Vc is 50 E power minus T divided by 1.6 milli. Okay. The question is not only ask you for Vc, it's ask you for the others. Okay. Okay. Now it's ask you for Vc at time equal to 0. Substitute them 0, give you 50 volt and give you 1.2 milliseconds. Okay. Give you here. Okay. Substitute 1.2 milli in here. Get here. You get 14.3 volt. Next step, determine IC. IC you can get from Vc. IC equal to C dV by dt. Okay. Or you can see that for time less than 0, Vc equal to 50 is a fixed. Okay. It's constant value. Therefore, IC equal to C dV dt. If Vc is constant, dV dt is 0. Therefore, IC is 0 due to Vc is constant. We assume any transition in the circuit dialog reading the pure DC circuit. Therefore, it's in the capacitor perform like open circuit. Or IC you calculate from Vc, it give you 0 amp. Okay. The next step IC for time greater than 0, it equal to 50 E power minus T divided by 1.6 milli. Take the derivative of them. Okay. Give you here. Okay. In the overall, give you minus 62.5 E power minus T divided by 1.6, okay, milliamp. Okay. Now, in the overall point of view, what happened? For time less than 0, the switch pressed in this position. This voltage source, 50 volt voltage source, will be charged the capacitor until it full charge. If it full charge, it perform like open circuit. Therefore, Vc equal to this voltage source, okay, equal to 50. For time greater than 0, the switch is pressed in this position. Okay, it means now it's no energy in there. It's have only the energy in the capacitor, and the capacitor try to maintain the voltage at its B. Okay, unfortunately, that the energy in the capacitor is not infinity. When it maintains the voltage, it will generate the current and loss in the resistor in here. Therefore, the voltage or the Vc will be drop depend on time. Okay. When time increasing, Vc will be dropped too. Okay. Now for time less than 0, it equal to 50. Time greater than 0, it will be decaying in the exponential form. Both of them is equal at that point at time equal to 0. You can get V naught in that step. Okay. Next one, the questions ask you for IC. IC for time less than 0, IC equal to C dV by dt. For time less than 0, Vc is constant. Its derivative is 0 too. Okay. And time greater than 0, okay, the derivative of them, okay, Vc is decreasing. Therefore, its derivative is mean the slope of that graph. The slope is decreasing. Therefore, it will become negative. Okay. IC will be decaying, and you can see that what happened to them. Why it decay? Because in the circuit after the switch is pressed, it have no more energy in here. It have only electric field energy in the capacitor. When the capacitor maintains the voltage at its B, it will be generate the current in here and it load in the resistor. Okay, that when the time is running, the voltage level that it try to maintain, it will be gradually drop. Okay, but the voltage or the VC cannot be suddenly drop. Okay, suddenly change. Okay, because from the capacitor characteristic, if VC change suddenly, I will be infinity. It's impossible in the real physics world. Okay, it's impossible. Therefore, VC will be gradually drop to 0 until it have no more energy in here. Okay, this is in the completely and overall solution of this question. The next topic discuss about the more general perspective. Okay, a more general perspective of this is mean if there are the several resistor and the inductor are present in the circuit and it can be combining using the series and or the parallel combination, then the equations then we can formulate them to be the equations 19 by here. Okay, you can see that is the time for the RL circuit. Okay, if you have many inductor, if you can combine them by use the inductor combination, you get the L equivalent in here. And in the circuit, if you have so many resistance, okay, you use the equivalent resistance you get in here, and you can find the time constant. Okay, we have consider the task of finding the natural response of any circuit which can be represented by an equivalent inductor in the series with an equivalent resistor. A circuit containing several resistors and several inductors does not always proceed a form which allows either the resistor and the inductor to be combined into a single equivalent element. The general RC circuit, many of the RC circuit for which we would like to find the natural response can be contained the several resistor and the several capacitor. Okay, for the RC in the same manner. If you have more than one resistor and more than one capacitor, you must combine them first. Okay, therefore you will use, okay, in the formula you use the equivalent resistor and the equivalent capacitor to determine the time constant and use them to determine the response of the RL and the RC circuit. Now, in order to make you clearly understand, we provide you the example first, okay, how to compute them. Okay, now in this, for the circuit of the following figure, determine and the sketch the inductor current and determine and the sketch the current I1 in here. Now in this case, before we analyze them, okay, before we analyze this circuit, we should simplify the circuit by using the resistor combination and the capacitor, and the inductor combination first. Okay, how to combine them? You can see that two of them. You can see that this inductor and this inductor, you can combine them. Okay, it will be in the parallel. The way to combine them is the same as the resistor in the parallel. 1 divided by L equivalent equal to 1 divided by 2 milli plus 1 divided by 3 milli. Okay, it gives you here. It gives you 1.2 milli. Okay, and two of them, 1 milli and 1.2, connect in the series. The equivalent inductance equal to the sum of them. Therefore, the result is the sum of them equal to 2.2 millihenry. Okay, 2.2 millihenry. And now you can see that for the uninteresting part of the resistance, you can combine them, such as the 60 ohm and 120 ohm in this case. You know that, okay, it's connected in the series and it have no interesting in here. You can combine them. Okay, you can combine them. Okay, and this part will be connected to this part. We will redraw them. 180, the equivalent resistance, 180 will be combined in this. Okay, 90 and the 180. Hey, you see them? You would like to combine them? No. Wait a minute. The questions ask you the current in I1. If you combine them, I1 is gone. Okay, we will combine them later, not now. Okay. Now, the first step, okay, for the RL circuit, you must determine the IL first. Now you already get equivalent inductance equal to 2.2 millihenry. Now the next step we checking first, okay, for time, okay, for time less than 0. For time less than 0, the switch is still contact in here. It means the voltage source is charged and supply the energies to all 4 devices, and it's already full. Okay, it's already charged the inductor until it full charge. For the inductor, if it full charge, it perform like short circuit. We assume any transient in that circuit died out long ago, leaving a purely DC circuit, and the inductor act like the short circuit to the DC current. Okay, yeah, you can see that. The interesting is IL, the current flow in the inductor, and in this case, 90, 180, and the 50 will be connected in the parallel to this voltage source. Therefore, you know that the voltage across this terminal equal to 18 volt. Therefore, IL equal to 18 divided by 50. Okay, from the Ohm's law, we can calculate IL equal to 18 divided by 50. Therefore, it equal to 360 milliamp. And for time greater than 0, IL for time greater than 0 is a little bit complicated in here. Okay, you can see that the switch is open in here. If the branch is broken, okay, the branch is broken, no current flow in here. Therefore, no power supply by this voltage source. You can discuss them. Okay. Now, in this case, you can see that we have 3 resistors connect in here. When you redraw the circuit clearly, you can see that 2 of them is connect in parallel and series with the 50. Therefore, the equivalent resistor in this case equal to, okay, 50 series with the parallel result of the 90 parallel with the 180. You see, 90 and the 180 in the parallel series with the 50. Give you 110 ohms. Okay. Now 110 ohm is the equivalent resistance that you get the time constant in here. Okay. Series with the equivalent inductance you get here. You substitute the time constant in the general form of the inductor's current. Give you here. Okay. Tau equal to 20 micro. 20 micro. Okay. Next step. Okay. For one. Okay. For time less than 0, I0, the inductor current equal to 360 milliamp. For time greater than 0 equal to I0, e power minus t divided by 20 micro. Okay. Both of them is equal when time equal to 0 by take advantage from the third characteristic of the inductor that state that it is impossible to change the current through an inductor IL by a finite amount in 0 time. From IL for time greater than 0, it equal to 360 amp, and IL for time greater than 0, it equal to I0, e power minus t divided by 20 micro. Yeah, both of them is equal. You can see that when you substitute 0 in here, e power 0 give you 1. You can conclude that I0 equal to 360 milliamp. Okay, and in this step, IL equal to here, you can summarize that IL equal to 360 e power minus t divided by 20 micro milliamp in the result. Okay. Now, if the questions ask you for more, in this case, the questions ask you for I1. Okay. Ask you for I1, you derive them from the circuit directly. Okay. For time less than 0, you can determine them from the circuit directly. But for time greater than 0, you must compute them from IL only. Okay. Now, for time less than 0, from the Ohm's law, you know that the voltage across this terminal equal to 18. Therefore, I1 equal to 18 divided by 90. 18 divided by 90. Time less than 0, I1 equal to 200 milliamp. But for time greater than 0, it's a little bit complicated. Okay. You can see that in this case, the switch is open. Okay. For time greater than 0. Okay. Therefore, the source is removed from the circuit. Okay. Therefore, in this case, I1. Try to express I1 in the term of IL. You can see that IL flow in here in this direction. At this point, IL will be split in 2 parts. One flow in the 90 ohm, one flow in the 180 ohm. Okay. Therefore, you can use the current divider in this step. I1 equal to IL, right? IL. Divide by, in the parallel, divide by, okay, multiply by 180 and divide by 90 plus 180. Okay, from the current divider, we can calculate I1 as it here. But in this case, you can see that the reaction of the I1 is a reverse than the IL, right? Therefore, minus will be in here. Okay. Okay. Substitute IL that you get from the previous step. Okay, you get here. The key for the RL, RC, and the RLC in the next lectures. Okay, the chapter 8 and the chapter 9. The difficult point is almost all parameters must compute from VC or the capacitance voltage or the inductor current. Therefore, if you compute two unknown wrong, the other will be wrong too. Okay, write the chain rule. Okay. Now in this case, you can conclude that I1 equal to minus 240 e power minus t divided by 20 micro. Okay, unit of them is milliamp. In the overall point of view, okay, for time less than 0, okay, the switch is still pressing and the voltage source is charging all three, okay. In fact, it's all device, okay, include the inductor, okay, and the equivalent inductor will be stored until it full charge, okay. If it full charge, it perform like the short circuit. Therefore, the inductor current equal to 360 milliamp constantly until time equal to 0. The switch is open. You remove the source from the circuit, okay? It's make the current, the inductance current, and the other current in the circuit will be gradually drop in the exponential form, okay? And for time greater than 0 and time less than 0, it's equal. You can find I0 at that point, the market point, okay? Next one, if you would like to find I1, the current flow in the 90 ohms resistance, okay? I1 for time less than 0 is constant because it still have some voltage source supply to them, okay? It have here equal to 200 milliamp. And for time greater than 0, okay, even though it don't have any source, okay, but it have some energy drive from the inductor current, okay, and the inductor current will be gradually drop, okay, due to the energy in the inductor is not infinity. The longer it try to maintain the current or it generate to be the current or the inductor current, okay, the more energy is deplete from the inductors, okay, until it deplete and until it's 0 soon, okay. Therefore, the result is here. Okay. Now the next one. In the case that, in this case, you can see that if for the case that short free in this circuit, okay, when for time greater than 0, the remaining circuit is here. If the circuit have some dependent source, remember that the question is considerably difficult. Why? Because you cannot find the equivalent resistance directly. You must use the previous skill, the previous theory to determine the equivalent resistance for that case. In this case, you must use the Thevenin equivalent circuit first to determine the equivalent resistance. If you don't determine R equivalent or the equivalent resistance, you cannot determine the response too, okay? From the circuit shown in this figure, determine and get the capacitor voltage for time greater than 0 if the questions already give you the initial condition. The capacitance voltage equal to 0 at time equal to 0. Okay. Before analyzing the circuit, we start by finding the Thevenin equivalent circuit of this network to the ref of the capacitor first. And in this case, you can see that the structure of them, which type of the Thevenin is. You know that the Thevenin have three types. The first one have only independent source. Second one have both source. And the last one have only dependent source. This type is the last one, the type 3. For the type 3, okay, circuit, you must add one independent source into them, okay? In this case, you can add the current or the voltage depend on you. In this case, okay, we first apply 1 amp current source to the circuit network, okay? At the top of this, okay, you can apply the KCL to them, okay? 3 current flow in here. You can see that 2 current get in, 1 current get out. Current get in equal to 1.5 I1, okay? And another one is 1 amp. You can see that 1.5 and 1 amp. One current get out is I1, okay? you can get I1. The key, you don't want to find I. You would like to find voltage across this terminal or voltage at this node. Okay. If you know I1, you can find the voltage across them. Okay. The voltage V equal to I1 multiplied with R. Okay. R equal to 30, 20 plus 1. Therefore, in this case, it gives you V test equal to minus 60. After you get minus 60, it means R equivalent equal to V divided by R. Okay, V divided by I. In this case, don't worry about the sign of the resistance that you compute from the Thevenin. It can be positive or it can be negative. You know that in the real world, the minimum value of the resistance is 0. But in this case, the Thevenin equivalent circuit is only the mathematics model. It's minus, it means when you feed power to them, it gives you the reverse direction of the voltage or the current at its B. Okay. Now, therefore, the equivalent circuit is already give you minus 60. Okay. Therefore, we redraw the circuit back. Okay. In here, the green part can replace by a single resistance equal to minus 60 ohm. Minus 60 ohm. Okay. And for here, you can determine VC. You determine the time constant of the RC circuit by time tau equal to R multiplied by C. It equal to minus 60 microsecond. Okay. And from the equations 14, we can find VC equal to V naught e power minus T divided by 60. And here, in this case, it's minus and minus. You can see that. Okay. Therefore, the V will be increasing. Okay. Therefore, VC will be increasing from time to time. Okay, due to the equivalent, the Thevenin equivalent circuit is makes the resistance positive. Okay, negative. Sorry. Okay. Now for time equal to 0, VC equal to 2 volt. Okay, VC equal to 2 volt from the questions given to you. You know that V naught equal to 2. Therefore, the general form of the solution of the VC is V naught equal to 2. Therefore, the general form of the solution of the VC is 2e power T divided by 60 micro. Okay. Oh. Okay. Okay, the time is already up. Okay. Okay. I will provide you only one question here. Capture it. Okay. Do it as the homework. In fact, you can find more exercise in the books. Okay. But you do it. Okay. And the next time I will call you about this answer from you. Okay. After you provide me in 5 minutes, first 5 minutes of the lecture, I will provide you the complete solution of this question again. Okay. To make sure that, okay, to check that, okay, the thing that you understand is right or wrong. Okay. Capture it in 5, 4, 3, 2, 1. Okay. I will provide the solution next time. Okay. Any question?
No ครับ
Okay. This class is finished. Okay. Good luck. Be careful about the COVID. Okay.
Yeah.
Save yourself. Okay. I heard that one ABAC student already infected due to the maybe go to the restaurant or the department store. I'm not sure. Okay. Save yourself, because if you are infected by COVID, okay, not only you, your family, and for yourself, if you must go to the hospital, admit the hospital maybe 2 or 3 weeks until you release. Okay. I'm not sure that you have the ability to take the final in time or not. Okay. If not, you might get the maybe late exam almost all subjects, or maybe fail in some subject. Okay. Therefore, first of all, even though I know that almost all of you maybe already grown, okay, you already know how to do, okay, but don't underestimate how easily it infected. Okay. Save yourself first, and you will save your family. Okay. Good luck. May the force be with you.
ครับ
Thank you,
โชคดีทุกคนนะ
Thank you
ระวังสุขภาพกันด้วยล่ะ ติดกันมาเดี๋ยวจะมาสอบตกกันเปล่าๆนะไป
Thank you.
You're welcome You're welcome.